Welcome to all of you. In this session, we are going to understand the verification of circular time shift property of DFT using the Scilab. Now let us go through the statement for this. So if DFT of x of n is equal to x of k, then DFT of x of n minus m with respect to n will be equal to omega n mk into x of k for all the values of k ranging from 0 to n minus 1. So this is the general, this is the expression what we have gone through, and it is also realized in this manner. But anyhow, we will be sticking on to this particular representation for the further process. Now let us consider an example for this one. So find the 4-point DFT of the sequence x of n and verify the circular time shift property. Now given sequence 1 minus 1, 1 minus 1. The sequence length is 4 and m will be equal to 2, and this value of m is applicable with respect to the circular time shift property. There we are going to use this value. So circular time shift property is given by this expression. So first we are going to have the realization of the LHS part. So first we are going to find out what is x of n minus m with respect to n. So that's what we have found first. Then apply the DFT for this one, and this is what the result we have got. So for this we are considering this is y1 of n, and after applying the DFT we are going to get y1 of k. So with respect to circular time shift property, we have got the LHS part, and then in order to calculate the RHS part, we need to have the DFT of x of n. That's what is being asked, and that we are going to find out, and that is present over here. So DFT of x of n is x of k, and for that we are going to get 0040. Further, RHS part of the property is x of k, that is available with us, that has to be multiplied with the total factor omega n mk. So n is value 4, m value we are having the value 2, and k is 0 to n minus 1 is what is its value. So we are considering that as y2 of k. By applying the property and the respective values, we are going to get y2 of k is equal to 0040. Now compare the values of RHS part with respect to LHS part. So both of them are equal. Hence the circular time shift property is proved. Now let us go through the Scilab program for this one. Now this is the Scilab program for circular time shift property verification. So whatever the example considerations we had taken, the same values has been put over here. So if you want, we can also feed a different value using these statements. So now x is equal to 1 minus 1, 1 minus 1 we have taken, length of the sequence 4, and m value we have taken it as 4. So the first part is we need to identify what is x of n minus m with respect to n. So we are going to get one more sequence for that. So that is being done in this part of the representation. After that we are going to have the value of xs, which is going to indicate x of n minus m with respect to n, right? So for that we are going to apply the FFT for that, and that is what one part of the answer we are going to have. Then in the another part we are going to have the total factor omega n m k multiplied with the x of k we are going to have, and that is what the RHS part of the realization that is being done over here, right? So for after this we are going to get the answer of RHS, and then we are going to make a comparison of LHS with that of the RHS. If both of them are going to be equal, then it is going to satisfy the circular time shift property. If not, then it is not going to satisfy the circular time shift property. Now let's have the simulation for the values that has already been considered. Now after execution, so LHS part 0040, and also the RHS part, it is 0040 is what we are going to have. Hence both LHS and RHS are equal, so it is going to put a message that the circular time shift property has been satisfied. Thanks for watching.